Hello and welcome everyone. In this chapter we are going to discuss about OSPF, DR and BDR concept. So yes, we will discuss about designated router and backup designated router concept here. So we'll talk about this all the features one by one of your designated and backup designated router. Before that, let's try to understand whether why we need this DR and BDR concept in this. So let's take an example here. Say for example that we are having a scenario here. Let's say we have a scenario is this like where I have the multiple routers like this, and the multiple routers are for sure connected with one of the device here, and this device I will consider as my switch. And right now the connectivity also like this you have. Say this, when you connect your multiple routers here and configure the routers in OSPF domain, when you configure your routers in OSPF domain, this kind of topology we basically called it as BMA topology, broadcast multi-access topology. Broadcast multi-access topology. Why? Because all the routers right now is connected via the LAN interfaces like Ethernet interfaces or maybe fast Ethernet interfaces here. So that's where you call it as BMA topology. This is also one of the BMA topology. Also, if you go ahead, take your routers, one router, and connect other routers here. Right now, this router 1 is connected with second router, and if they are connected with LAN interfaces here, this is also considered as your broadcast multi-access topology. Okay, so make sure wherever you have the broadcast multi-access topology, in the sense whenever you connect Ethernet interfaces to your routers, it becomes the BMA topologies. And of course, in BMA topology only the concept of DR BDR is going to be. So make sure DR and BDR concept you will find only when you have the BMA topology, broadcast multi-access topology. Okay, so let's try to understand whether when it is needed and what's the actual requirement of this DR and BDR. So I will discuss about DR and BDR. Before that, let's discuss some of the issues here, the scenario here. So take an example. Let's say that we have got a new router here. Let's say we have got a new router here. New router is connected to this. So when you connect your routers by using the serial interfaces to another routers, this kind of connectivity is basically called as point to point connectivity. In case of point to point connectivity, there is no DR BDR concept, only master and slave concept will be there. Very simple, the router with highest router ID will become the master, second highest router ID will become the slave. And the job of master is to send the update first, and then slave will send the update. Simple. So right now we need to understand DR and BDR. So let's say this is my router 5, and this router 5 is basically connected to some of the network. Let's say the network is 10.0.0.0/24. This is a network, fine. And let's say I am going to configure the OSPF in this as well. The moment you configure OSPF, the routers will advertise the update into this domain. The routers will advertise the update, and this update says, hey, update is 10.0.0/24 goes to router 1. A router 1 will now advertise this to its neighbors. Right now if you check the neighbor for router 1, how many neighbors? For router 1, router 5 is the neighbor. Also, the routers which is connected through Ethernet 0, in the sense switches, this all the routers like router 4, router 3 and router 2 also becomes neighbor. Similarly for router 2, router 4, router 3 and router 1 is the neighbor. Similarly, when it comes to your, let's say, router 3 or maybe router 4, for them this is neighbor and this is neighbor. So make sure whenever a update is being received from router 5 to router 1 will forward this update to switch. Now switch will send this to this, this and this also. All the routers has got the update. Later on, the routers of your other, like router 2, router 3 and router 4, the routers are running with dynamic routing protocol. They will say like, hey, we are receiving the new update, we should forward this update to our neighbor. So whenever this update is coming to router 2 will say, hey, I need to forward this update back. So this update will go to this, update will go to this, update will be received here. Similarly, router 3 will say, I am receiving a new update, let me forward this update to my neighbors. So this update will come to this update will come to this, come to this. Similarly, your router 4 will think that yes, I am receiving the new update, I should update to my neighbor. So this update will be forwarded to this all. So like this update will be keep on moving between the routers here. Why this is keep on moving? Because one router is neighbor to all other routers, and the dynamic routing protocol nature is if they are receiving any update, they should update to all other routers here. That's it. So this is basically a single update is moving between these all the routers, and this is the problem itself. And to overcome the same problem, we have got the concept of DR and BDR. We have got the concept of DR and BDR. Okay. So just to avoid this particular broadcast storm, we have got the DR and BDR concept. Okay. So let's do that. Once we have the DR and BDR, let's see how the update is going to travel here. Say this. First of all, I will erase this since I don't need right now. Okay, I don't need. Okay, done. Now see. So when it comes to DR and BDR, you need to understand the DR BDR election process. Make sure DR and BDR election will take place during the neighbor formation itself in two-way states. And read this. When it becomes DR, when it becomes BDR, that's very important to understand now. See. So the common point is the router with highest priority will become DR. The router with highest priority will become DR, and second highest priority will become BDR. DR stands for designated router, BDR backup designated router, and the default priority is 1 for all the routers. What happens in case of tie? In case of tie of the priority, the router with highest router ID will becomes the DR, and the router with second highest router ID will become the BDR. Okay, say this. So right now, if I talk about the priority, so priority for all the router is 1. For all the router is 1. All the routers has the priority as 1. So right now you cannot decide which router is the DR router. So that's where you will talk about the, because it's getting tied. So you will go to second criteria, that is router with highest router ID. Consider this router name like router 1, router 2, router 3 and router 4. This is itself a router ID. So in this case router 4 is having the highest router ID. So this router will become DR. This will become DR. A router with second highest router ID will become the BDR. And other than DR and BDR, all other routers are considered as DR other, DR other, DR other. Now DR other, DR and BDR election is done. Now see what happens once the update is traveling in this scenario. Say this. So I am going to configure OSPF in router 5. Router 5 will advertise the update here. Router 5 will advertise the update. This update goes to switch. Switch will now forward to all. Router 4, router 3, router 2 will receive. Correct now? This was the previous scenario before DR and BDR. But now what happens? Now we have the DR and BDR concept. This scenario will change completely. Right now what happens? The moment the update is receiving here at router 1, the update is being received here at your router 1. Now router 1 job is to update the DR and BDR. DR and BDR. BDR job is to take the update and keep quiet. BDR job is to take the update and keep quiet. Now DR will update the DR other. See that? Whatever DR is giving to router 2, just take the update and keep quiet. Don't send it back. See that all the routers has got the update and there is no frequent SPF algorithm is running and no frequent update is traveling between the routers here. So this is how you can avoid that particular problem by using DR and BDR. Now the point is, what happens when the DR other sending update to DR and BDR? What will be the address? If you remember, in OSPF there is two different address you have, 224.0.0.5 and 224.0.0.6. So what was the actual concept behind that? It is here only. See, this is actually talking about here. When DR other, see, when DR other is sending update to DR and BDR, it will use the address of 224.0.0.6. And when DR is sending the update to DR others, it will use the address of 224.0.0.5. Basically it is here. See, when DR other is sending update to DR and BDR, this address which is being used, this one is 224.0.0.6 and this address is 224.0.0.5. Simple. Now see, let's talk about little more here. Say for example, what if your DR is going down? If DR goes down, say for example, DR goes down. If DR fails, your BDR will become the next DR. And now the election will take place between these two routers and this will become the next DR. Okay, this will become the next DR. Correct? This will become the next DR. This is the normal process. Now let's say your DR is coming back. Let's say your DR is back now. What happened if your DR is back? If your DR is back right now, it will advertise that, hey, I am DR here. So the concept is, if a router is selected as the DR and BDR, so they will never change their state. They will never change their state until you do the re-election, manual re-election, and there is no automatic re-election in the DR and BDR concept here. So when your previous DR is coming, it will work like a DR other, because it will advertise, hey, I am the DR. This router will say, hey, DR is here already. So it will work like a DR other. But I want this particular router 4 should become as a DR. So in this case, you need to perform the manual re-election. How you can perform the manual re-election? See, there is a very basic process. You need to go ahead and clear the OSPF process. You need to define this command. Actually, you need to define this command, that is clear IP OSPF process. You need to define this clear IP OSPF process in all the routers, and it will ask for yes or no. You need to say yes and hit enter. So clear IP OSPF process you need to define in all the routers. You need to run this command in all the routers at the same time. And when you run this command in all the routers at the same time, the routers will break the neighbor relationship, and now they will try to form the neighbor relationship. and while forming the neighbor relationship, the routers will go for re-election, where it will say router 4 is my DR and this is my BDR and this is my DR other. Like this the process will take place. So make sure there is no automatic re-election, non-preemptive. The DR and BDR election is non-preemptive. So you need to do the manual re-election here. That's very important. Say for example, if I go ahead and change the priority for any router as, let's say, for this any router priority as, let's say, 0. If you change the priority as 0, this router cannot become DR, it cannot become BDR. It will always work like DR other. That's very important. If you change this priority to 0, this router will work like DR other only. It will not participate into DR and BDR elections to become DR or BDR. Simple. And in case if you want to force a router to work like, let's say, DR forcefully, so in that case you do have the option like go to priority and change the priority to little more, maybe 10. So it is 10, here it is 1, here it is 1, here it is 1. So this router will become the DR router because you have changed the priority. Make sure after changing the priority also you need to do this particular preemption by using the clear IP OSPF process command. Then only it will become the DR and BDR basically. So you can force a router to work like a DR by changing the priority, and the priority range is between 0 to 255. And you can change the priority to 0 for some of the router where the routers will always work like a DR other. Simple. So that's it. This is what your DR and BDR concept. I'll get back to my discussion here. Say this. So you can see, yes, we have done this already. Correct? Now, read this. If router priority is set to 0, it cannot become DR and BDR. That router will always work like DR other. And router which is not DR and BDR, they are called as DR other. Of course, yes, DR other. DR and BDR election is non-preemptive, and we can manually set the priority to force a router to become the DR. You can change the priority itself. Now, one more thing. If you remember, we discussed in OSPF, you have two different type of neighbor. One is just adjacent and another is fully adjacent. Adjacent in the sense they are just neighbor, but they will not exchange update. Fully adjacent in the sense they are neighbor and they will exchange the update also. For example, you see, do you think router 1 and router 2 will exchange the update together? Who is responsible to update this route R2 in this scenario? Your DR router, correct? No? So right now this R1 and R2 both are just neighbor. Both are just neighbor. They will be stuck into two-way state. They will not exchange update. But router 1 to router 4 or maybe router 3, they are neighbor as well as they are exchanging the update also. So they will be into which state? They will be into full state, fully adjacent. This is fully adjacent and this is just adjacent. We are just neighbor, hi, hello, but we will not exchange update together. That's what your DR and BDR concept here. Moving ahead, say this. That's what here is talking about. In case of neighbor, you have DR and BDR has the relationship with DR other as full state. Similarly, DR other to DR and BDR, they will be in full state. But DR other to DR other, DR other to DR other, they will stuck into two-way state. Just adjacent. No update exchange will happen here. But here they are fully adjacent. The updates will take place in this. That's it for this particular DR and BDR concept. We do have the OSPF metric calculation to understand, and this is also a very important point. So as we discuss for OSPF, we have the cost as a metric. We have the OSPF cost as a metric, correct? And cost is nothing but it is basically your reference bandwidth divided by interface bandwidths. And the by default reference bandwidth is 100 Mbps. By default reference bandwidth is 100 Mbps. If you convert this in bits per second, it will become 10 power 8 divided by bandwidth in bits per second. You need to calculate. For example, 10 power 8 divided by bandwidth in bits per second. This is equal to cost. So for example, if you have 100 Mbps of connection, how you can calculate the cost? It is about 100 Mbps is nothing but 10 power 8 bits per second divided by 100 Mbps. The cost will be 1. If you want to calculate the cost for this 1.5 Mbps serial interface, so it is about 100 Mbps divided by 1.54 and the cost will be 64 here. Like that you can see the scenario here. See, for serial interfaces, this is my bandwidth and this is cost, default OSPF cost. This is basically default OSPF cost. For Ethernet, it's like 10 Mbps of speed, so you will be getting this 10. For fast Ethernet is 1. For gigabit is also 1. So this is OSPF metric. If you want to change the OSPF metric for interface basis, you can go ahead and change this as well. See here. Take an example in this scenario. Right now 10 Mbps, 10 Mbps. What will be the reference bandwidth for this? I mean cost for this. The cost is 10. The cost is 10. For this the cost will be 10. For this the cost will be 1. So consider this is my source router and this network 40.network is my destination. So what will be the total cost and what will be the best path here? So to reach this particular 40.0.0.0/8 from router A, I have two paths. I can go via B, I can go via C also. So via B, what is the cost? Via B, 10 plus 10, 20 plus 1. So total it's going to be 21. And via C, 10 plus 1, 11 plus 1, 12. Just 12. So which is going to be the best here? Least will be the always best via C. Means your A can reach to particular 40.network via this. This is going to be your best path. Fine. So this is basically a very basic scenario where we need to keep in mind. Now, in case if you want to change the interface bandwidth, you can go ahead and change by using this command. It's all about, say for example, between these two routers, this is my serial interface. And for this by default 64 is the metric. If you want to change this to, let's say, something different, let's say I want to change this to 100. So you can go ahead and you can change the particular interface bandwidth itself here. See this, how to change? You will go to interface mode of routers and say interface serial, and serial is, let's say, serial 0 or maybe serial 1, and then IP/OSPF cost, and you can define the cost value as 100. It will be changed. So if you want, you can change the interface bandwidth as well as interface cost directly. So how to change the cost? This is the command. So command is very simple. It will be like interface serial 0, and then you will say the IP/OSPF cost is 100. That's it. Exit. This is how you can change the OSPF cost for interface basis. So in this chapter we have discussed about OSPF DR and BDR concepts. Also we have discussed about OSPF metric cost calculations. And in the next chapters we will show you the demo for DR and BDR and also how to change the bandwidth for the interfaces. So that's it for this particular lecture. Thank you. See you in the next chapter.